you on CuriosityStream.
I'm James Burke. I'm going to take you on a journey through time.
James Burke's visionary series returns, reimagined for our time.
Now, this is all uncharted territory.
The Washington Post hails Burke as one of the most intriguing minds in the Western world. The New York Times raves he careens from one great moment in history to another.
Where do we want to go from here?
Experience all new connections.
So what's the next connection?
With monthly, annual, and bundled plans, find the one that works for you at CuriosityStream.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 23, Episode 134, for broadcast on the 14th of December 2020. Coming up on SpaceTime, Hayabusa2 lands at Woomera, hints of new physics in light from the Big Bang, and SpaceX's latest Starship prototype explodes during landing. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The first pristine samples of an asteroid have been safely returned to Earth, with the Japan Aerospace Exploration Agency's Hayabusa2 re-entry capsule parachuting down onto the Woomera Rocket range in outback South Australia. The capsule was seen streaking across the sky over central Australia in the lead-up to its touchdown in the early hours of Sunday morning. And crew aboard the International Space Station also reported seeing the fireball during the re-entry. Once safely back on the ground, the re-entry capsule was quickly located by helicopter-mounted recovery teams from the Australian Space Agency and JAXA. Launched back in December 2014 on an H-2A rocket from the Tanegashima Space Center south of Tokyo, Hayabusa2 arrived at the near-Earth asteroid Ryugu in June 2018. The probe spent 18 months studying the kilometre-wide diamond-shaped asteroid, sending down 4 small lander rovers to explore the surface. However, the primary goal of the mission was sample return, both from the surface and from deeper down, where material hadn't been subjected to space weathering. The first of 2 planned surface sample collection operations was so successful, collecting quite a significant amount of regolith, the planned second attempt was eventually cancelled. Sampling involved firing a small projectile into the surface to kick up some debris ejector, which was then retrieved by a catcher on the spacecraft. But collecting material from deeper down inside the asteroid involved a far bigger impactor. That was fired by a small spacecraft deployed by the Hayabusa2 mothership, which had moved to a safe location during the firing sequence and impact. The impactor excavated a huge crater 10 metres wide, exposing pristine material, which was then collected by Hayabusa2. Its mission completed, Hayabusa2 departed the asteroid in November 2019 for the 300 million kilometre journey back to Earth. Then on Saturday, at a distance of 220,000 kilometres from the Earth, Hayabusa2 released its flying saucer-shaped sample return capsule. At an altitude of 120 kilometres, the 40-centimetre wide capsule hit the Earth's atmosphere at 12 kilometres per second, protected by its heat shield. It successfully deployed its radar-reflective parachute at an altitude of 10 kilometres, ejecting its heat shield and transmitting a position beacon signal, allowing recovery teams to quickly retrieve the spacecraft and its valuable cargo. Meanwhile, Hayabusa2 retains enough fuel for a follow-on mission. JAXA has now targeted a high-speed flyby of the Apollo Group asteroid 2001 CC21, that's slated for July 2026, and there'll be a rendezvous with the near-Earth asteroid 1998 KY26 in July 2031. Dr. Ellie Sansom from the Curtin University's Desert Fireball Network was part of a team of scientists in South Australia for the spacecraft's return to Earth following its 3.8 billion kilometre journey. She says the 4.5 billion-year-old samples contained in the re-entry capsule will provide new clues about the origins of amino acids, the building blocks of proteins, essential for life as we know it.
It came exactly on time. This glowing dot up just above the horizon started getting brighter and brighter and streaked overhead with this gorgeous tail as it kind of flew off in towards the southeast. And we were stationed at, I personally was stationed at Cuba PD, and it was amazing to watch.
Did many of the locals bother having a look? I mean, they're a pretty rough mob out at Cooper Pedy. I've been there, and it's the only place I know where they drive around with the words explosives all over their trucks because they're carrying explosives for the opal mining.
I'm not quite sure how many locals were around to watch it. We were stationed quite far out of town to get away from the light pollution of Cooper Pedy. So our team actually had 9 stations along the Stuart Highway to observe this event from different positions to try and get a bit of an idea of what was happening at the start, at the middle, and at the end. I'm a member of the Desert Fireball Network at Curtin University, and we have cameras across Australia designed to take pictures of these shooting stars that we call fireballs. But they're so rare that I've never seen one myself in real life, so this is an amazing experience to see it in person and not just on my screen.
Of course, this wasn't really a fireball in the sense that it was a meteor. This was a human-made object returning to Earth. Are the dynamics similar?
Yeah, so they actually come through the atmosphere very similar, and that's basically what we were out there trying to do with our science team, is to use this amazing event from JAXA to actually test our science for natural objects. So we have, like I said, we've got cameras all the way across Australia taking pictures of these fireballs so that from different positions we can figure out where these space rocks are coming through our atmosphere. And from those different positions, we can get an idea of that trajectory and figure out where something might land on the ground if it drops a meteorite, which is really pretty cool. But the other thing we can do is we can backtrack and figure out where in the solar system it came from. And although we have lots and lots of data and we have recovered meteorites, we know that side works, but we don't have very many test cases of figuring out how well we can calculate orbit. And this is an amazing example that we can use, that we knew exactly when it was coming in. We could have everything set up. We could take our images and we can now use this to test how well we can calculate the orbits of our meteorites.
And what sort of equipment did you bring with you for something like this?
We actually had a lot of stuff out there. We had over 50 pieces of equipment out there, and not only our own from the Desert Fireball Network team take pictures and video, but we actually were incredibly honored to be given the responsibility of actually performing science on behalf of our Japanese colleagues that weren't able to come over to Australia because of COVID. And this is something, all of these instruments that we had planned have been planned for over a year. And then as we've been going through the year, we've been stepping from plan A to plan B to plan C, and I think we're on F4G or something by now. But we had seismometers out there. We had what was called infrasound, and infrasound is basically microphones. So both the seismic and the infrasound were listening for the fireballs. They were trying to listen for that sonic boom when something coming in at 12 kilometers a second is going to create as it comes through the atmosphere. And we had quite a few of those all the way along the Stuart Highway, like I said. And actually, after the fireball event ourselves, I think that was the most incredible part about it, was sitting there really, really quietly for about 5 minutes waiting to see if we could hear the sonic boom with our own ears. And I wasn't expecting to be able to, but we did. And it was really, really cool. It was like someone had set off a mine blast a couple of kilometers away, and that was amazing as well. So
it wasn't a crack like you normally get when a spacecraft comes down. Normally you get a double crack. It wasn't like that. It's a very similar concept. You're getting this sonic boom from that, what we call a hypersonic. It's not even supersonic. It's a hypersonic trajectory as it's coming in. But that's actually a really good question, is that we don't know what that sonic boom is going to do at different points in the trajectory. Is it going to be a double bang? Is it going to be a single bang? Are we going to be able to hear it at all? And our station in Cuba Pedy heard it, but those stationed up in Marla didn't, and those stationed quite a bit further down in Bonbon didn't either. So that's why we had these sensors all the way along, so we can actually try and maybe characterize what's actually happening. We also had some UHF receivers, so just listening for the radio waves, if there were any cool radio waves being transmitted by the plasma, basically the burning atmosphere behind this capsule, to see if we could hear that in the radio. So yeah, we had quite a few things out there, and it was quite nerve-wracking because we've been given this amazing responsibility of putting out this equipment for our colleagues.
and it was quite stressful, hoping that we'd done a good job. But I think we got some really, really good data.
When do you hit thicker atmosphere, which is thick enough to cause that plasma to start up?
That ionization kind of the atmosphere, yeah. Again, a really interesting question. It kind of depends on the speed that something's coming in at. So if you've got a thin atmosphere, but you're going really, really fast, it apparently feels a lot thicker. So when we're looking at meteors, especially meteor showers, that's usually small pieces of dust, probably about the size of a grain of sand, and it happens maybe takes about a second and we see that. But what the Desert Fireball Network does is we're looking for fireballs, which are really, really bright meteors, and they're usually a lot bigger. So they can sometimes come in about the size of a washing machine and maybe drop a meteorite the size of your fist. And there's some different speeds and dynamics that are in there. So the dusty stuff can come in up to 72 kilometers a second. It's really, really fast. And they'll start burning at about 100 kilometers altitude. So they won't survive very long. Yeah, so they won't survive very long. Whereas our fireballs, our bigger objects, are going a lot slower, very, very similar to this Hayabusa capsule, actually. About maybe 12 to 20 kilometers a second is not typical. And they'll usually start burning at about maybe 80 kilometers altitude. But it's all over by about 25 to 30 is where we usually see natural objects stop burning. And Hayabusa was, I think, pretty similar to that. But of course, the difference with the Hayabusa is that it popped the parachute out after that phase, whereas our space rocks just have a natural ballistic trajectory to the ground.
All of a sudden, they're no longer meteors, but meteorites.
Yes, indeed. Yes.
So one of the great things about this was the fact that you knew exactly what trajectory it was coming in on.
We had a station up in Mala, and we brought people all the way down to just around the Bonbon area.
And translating this to the Desert Fireball Network, how does that help you?
Well, this is just an absolutely amazing, unique test of our system. So although we obviously know the trajectory, we can actually use our systems to recreate that trajectory and see how well we match. Is the first step, which will be really cool. And then we can also use that to figure out, well, let's see where the capsule would have maybe landed if it didn't have a parachute. That'll be an interesting test as well. We can obviously put the parachute in there and then see how well we match our fall position to the ground with as where the capsule landed. But again, as I said, the really awesome thing is we can test how well we can calculate orbit. So Hayabusa2 is an incredible mission of what we call a sample return mission. So it's gone all the way out to an asteroid, it's collected a sample of a known asteroid, and it's brought it back to Earth for us to study. And this is only the second time ever this has happened to an asteroid, and the first one being JAXA's Hayabusa1. So they're obviously getting really good at this. But it is obviously, really rare to know where samples are coming from in our solar system. And meteorites are incredibly valuable trying to figure out what was going on in our early solar system, whether they're basically primitive, really, really primitive rocks, and they can tell us a little bit about how the solar system formed, how it evolved. But of those 60,000 meteorites people have randomly picked up around the Earth, there's less than 40 ever that we've observed with cameras to figure out where they come from.
Wow.
So trying to get the context of those rocks is really rare as well, even for the ones that we have here on Earth. So that's what the Desert Fireball Network is doing. It's trying to do a little bit of not quite a perfect sample return mission, but it's trying to give that spatial context to the rocks that we have here on Earth. And we've got teams at the Space Science and Technology Center at Curtin University who are science team members of the Hayabusa2 mission, and they're going to be part of studying those samples that they've brought back, which is really cool.
There are Australian scientists that'll be involved in analysing the samples once they're opened up.
There's quite a few science team members across Australia, yes.
What will we learn from pristine samples of meteorite, which, well, actually you wouldn't call them meteorite, would you? What do you call them? Meteoroids, I guess. Pristine samples of this space rock. What's the advantage of looking at those as opposed to the meteorites you find on the ground?
Well, the really cool thing about these space rocks is these samples we know exactly which asteroid they came from. And they came from asteroid Ryugu. And Ryugu is very special. It's what people think might be a similar parent body to carbonaceous meteorites on the ground. And carbonaceous meteorites, we've recovered quite a few. They've been known to contain amino acids, and they're super, super primitive rocks. And if we can find amino acids in these samples from Ryugu, we might be able to start piecing together that story of where life on Earth came from, which is pretty amazing. So we have these rocks and these meteorites on Earth that we haven't really got a very good match to those asteroids that we're seeing with telescopes. So trying to match meteorite to asteroids can help us try and figure out a little bit more about what's out there and also maybe where we came from.
I got the opportunity to have a close examination of one of the Murchison meteorites, which was absolutely, just to look at it and realize...
Perfect carbonaceous meteorite.
Here's a carbonaceous chondrite. It's absolutely brilliant, full of amino acids. And in fact, of course, that one made history. We discovered that, hey, there are lots of amino acids out there in space. These building blocks for life.
Murchison meteorite is a perfect example of a carbonaceous meteorite. And that fell about 51 years ago now, when we still don't know where it came from. So we've got those samples of amino acids, but we don't know where in the solar system it came from. And maybe these samples that Hayabusa2, the capsule that it dropped, has given us is samples of possibly where those might have come from. Asteroids similar to asteroid Ryugu.
That's Dr. Ellie Sansom from Curtin University's Desert Fireball Network. And this is Space Time. I'm Stuart Gary. Still to come, hints of new physics in light from the Big Bang. And SpaceX's latest Starship prototype explodes during landing. All that and more still to come on Space Time. Scientists have glimpsed hints of new physics in Planck data from the cosmic microwave background radiation. The cosmic microwave background radiation, or CMB, is a time 308,000 years after the Big Bang, some 13.82 billion years ago, when temperatures had cooled down enough for protons and electrons to combine to form the first neutral hydrogen atoms, in the process allowing photons to be released. The entire sky is imprinted with this relic radiation, now cooled down to just 2.7 degrees above absolute zero, and glowing brightest in microwaves. Ripples in the cosmic microwave background are produced by slight irregularities which appear as minute temperature variations caused by differences in density at the moment the CMB occurred. And the fine details in these ripples encode for how much dark matter and normal matter there is in the universe. The study's authors developed a new method to measure the polarization angle of the cosmic microwave background radiation by calibrating it with dust emissions from the Milky Way. While the signal's not being detected with enough precision to draw finite conclusions, it seems to suggest that dark matter or dark energy is causing a violation of so-called paritory symmetry. Now, this is important because the laws of physics governing the universe are thought not to change when flipped around in a mirror. For example, electromagnetism works the same regardless of whether you're in the original system or in a mirrored system in which all the spatial coordinates have been flipped. Now, if this symmetry called parity is violated, it could hold keys to understanding the elusive nature of dark matter and dark energy, which occupy roughly 25 and 70% respectively of the total mass energy budget of the universe today. While both are called dark, these two components have opposite effects on the evolution of the universe. In this case, dark simply means science doesn't understand them. In the case of dark matter, well, it attracts gravitationally, while dark energy causes the universe to expand at an ever-accelerating rate. So one's pushing things together, and the other's pulling them apart. The new findings, reported in the journal Physical Review Letters, suggest a tantalizing hint of new physics violating paritory symmetry with a 99.2% confidence level. The key to all this has been the polarized light from the cosmic microwave background. Light is a propagating electromagnetic wave. It consists of waves oscillating in a preferred direction, which physicists call polarized. Polarization arises when the light's scattered. Sunlight, for instance, consists of waves with all possible oscillating directions, therefore it's not polarized. The light in a rainbow, however, is polarized because the sunlight's been scattered by water droplets in the atmosphere. Now, in a similar way, light from the cosmic microwave background initially became polarized when scattered by electrons 380,000 years after the Big Bang. As this light's traveled through the universe for some 13.82 billion years, the interaction of the cosmic microwave background with dark matter or dark energy could cause the plane of polarization to rotate by an angle beta, denoted with a lowercase Greek letter. Now, if dark matter or dark energy interact with the light of the cosmic microwave background in a way that violates planetary symmetry, scientists could find its signature in the polarization data. To measure the rotation angle beta, the authors needed polarization-sensitive detectors, such as those aboard the European Space Agency's Planck spacecraft. And they needed to know how the polarization-sensitive detectors are oriented relative to the sky. If this information is not known with sufficient precision, the measured polarization plane will appear to be rotated artificially, thereby creating a false signal. Now, in the past, uncertainties over the artificial rotation introduced by the detectors themselves limited the measurement accuracy of the cosmic polarization angle beta. So the authors developed a new method to determine the artificial rotation using polarized light emitted by dust in the Milky Way. And this allowed them to achieve a precision double that of the previous work, allowing them to finally measure beta. You see, the distance travelled by light from dust within the Milky Way is much shorter than that of the cosmic microwave background. Now, this means that the dust emission isn't affected by dark matter or dark energy. In other words, beta is present only in the light coming from the cosmic microwave background, while the artificial rotation affects both. So, the differences in the measured polarization angle between the two sources of light can measure beta. The authors then applied the new method to measure beta from the polarization data taken by Planck. And astonishingly, they found a hint of violation of planetary symmetry with 99.2% confidence level. But to claim a discovery of new physics, a much greater statistical significance, a confidence level of 5 sigma or 99.99995% is needed. So, the work continues. It's close, but no cigar. This is SpaceTime. Still to come, SpaceX's Starship prototype explodes in a ball of flame during landing. And later in the science report, we don't say this often, but we'll report on a major breakthrough in science which is destined to change everything. All that and more still to come on SpaceTime. A prototype of the new SpaceX Starship has exploded in its spectacular fireball following a test launch in South Texas. The suborbital test flight was designed to use its Raptor engines to launch vertically, climb to an altitude of 47,000 feet, before maneuvering into a horizontal position called belly flop in order to simulate a controlled re-entry and descent from orbit. Then, as it neared the ground, it would return to its vertical orientation for landing. The unmanned mission went exactly according to the flight plan. That was until just seconds before touchdown, when it became clear that Starship was going down too fast, crashing into the ground and exploding in a massive fireball near the landing pad, or as SpaceX boss Elon Musk puts it, a rapid unscheduled disassembly. The 122-metre tall, gleaming, silver bullet-shaped Starship looks like something lifted straight out of a 1930s Flash Gordon comic strip. Constructed out of stainless steel, Starship's designed to ultimately replace SpaceX's existing Dragon, Falcon 9 and Falcon Heavy spacecraft with this massive super heavy lift launch vehicle. Musk describes Starship as an interplanetary colonial transport vehicle capable of carrying 100 people or 100 tons of supplies and equipment on missions to the Moon, Mars and beyond, or 150 tons of equipment into low Earth orbit. Technically, Starship's only the upper stage of a two-stage rocket. The lower core stage, called the Super Heavy, will be powered by 28 Raptor rocket engines, compared to the 6 used on the upper Starship stage. The methane and liquid oxygen-powered Raptor rocket engines operate at extremely high pressures, and managing them has been a difficult challenge, with several prototype test articles destroyed during static fire ground tests and low-level hops. Musk only gives Starship a 1 in 3 chance of surviving its maiden flight, saying a lot of things need to go right, which is why prototypes SN9 and SN10 are already waiting in the wings. Musk's already planning a manned space tourism flight around the Moon using Starship, and NASA are looking at using Starship to land people on the lunar surface. Musk's real dream, however, will see Starship transport the first human colonies to Mars. And he's predicted a manned test flight to the Red Planet could happen as early as 2026. That's a good 10 years earlier than NASA. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Researchers have achieved a major breakthrough in science, which is destined to change everything. An artificial intelligence deep learning program from the DeepMind Lab has made a gargantuan leap in solving one of biology's greatest challenges, understanding protein folding. Protein folding is the process by which a protein takes its shape from a sequence of building blocks called amino acids in order to create its final three-dimensional structure, which in turn determines how the protein works and what it does. By understanding how proteins fold, scientists can better understand key biological processes, make life-saving drugs and medicines more quickly, revolutionize bioengineering research, vastly accelerate efforts to understand the building blocks of cells, and even make softer ice cream. DeepMind's program called AlphaFold outperformed around 100 other teams in a special protein structure prediction challenge. AlphaFold structural predictions were indistinguishable from those determined using the current gold standard methods, such as X-ray crystallography and cryo-electron microscopy, which are both laborious and expensive. Plus, AlphaFold structural predictions will make it possible to study living things in new ways. A new study has warned that human activity causing habitat destruction has resulted in less than half of the world's forests still being in their natural state. The findings, reported in the journal Nature Communications, show that only around 40% of the world's forests are still functioning as they naturally should, and only 56% of protected forests are functioning naturally because of human activity. Scientists found that globally, just 17.4 million square kilometres of forest is still in its natural state, mostly in Canada, Russia, the Amazon, Central Africa and New Guinea. But only 27% of this area is protected. The study warns that the few remaining natural forests now urgently need protection. A long-awaited report by the National Academy of Sciences has confirmed that a mysterious neurological syndrome experienced by American diplomats in Cuba and China is consistent with the effects of directed microwave energy. The findings, which support the long-held suspicion of American intelligence officials, could not prove that Havana syndrome, as it's called, is produced by a weapon, but it does raise that disturbing possibility. US intelligence officials suspect Russia was behind the attacks, which targeted diplomats and CIA officers. A team of medical and scientific experts studied the symptoms of 40 State Department and other government employees, concluding that nothing like this had previously been documented in the medical literature. Victims reported hearing a loud sound and feeling pressure in their heads, and then they experienced dizziness and unsteady gait and visual disturbances. Many have suffered debilitating, long-lasting effects. The symptoms are consistent with the effects of directed pulsed radiofrequency energy, and Russian intelligence agents working on microwave programs just coincidentally happened to be present in the same cities at the same times as the embassy staff suffered their mysterious symptoms. In 2016, more than 24 US and Canadian diplomats stationed in Havana, Cuba, began hearing strange sounds and experiencing bizarre physical sensations, including hearing loss, balance and cognitive changes, along with mild traumatic brain injury. And then in 2018, American diplomats in China began experiencing similar symptoms. Just last month, Beijing confirmed that China has been using a directed high-energy microwave-based weapon system against Indian troops in the disputed Himalayan border region, literally cooking them alive. Paleontologists have discovered a new species of sauropod dinosaur in Argentina. Sauropods are those dinosaurs that look like Fred Flintstone's pet Dino, with an elephant-like body and legs, a long neck and small head at one end, and a long tail at the other. The newly identified herbivore, named Baqualia alba, weighed around 10 tons and was about as big as 2 African elephants. A report in the Journal of the Proceedings of the Royal Society B suggests that the remains of at least 3 individuals, including a partial skull and cervical vertebrae, were found in 179 million-year-old strata at a dig site in the Bacul Canyon region of central Patagonia. Leading medical campaigner, Associate Professor Ken Harvey, has resigned from the Therapeutic Goods Administration's advertising committee, citing years of frustrations over its kid gloves treatment of complementary remedies. The Therapeutic Goods Administration, or TGA, is supposed to be Australia's regulatory authority for medicines, similar to the Food and Drug Administration in the United States. It's meant to undertake a range of assessments and monitoring activities to ensure that all therapeutic drugs available in Australia are of an acceptable standard. The TGA received some 1,468 complaints in 2018-19 about advertisements for drugs and devices, many of them alleging herbal supplements, fat burners and hangover cures that were sold with wild and unsupported claims about their effectiveness. Tim Mendham from Australian Skeptics says Harvey claims the agency's simply grown too close to those it's meant to regulate.
Ken Harvey has been a noted campaigner against sort of the more extreme claims of alternative medicine providers, particularly through the advertising and what they're claiming there. He's been a member of the TGA panel, the Therapeutic Goods Administration panel, which reviews advertising and claims for some time. And from within that role, he's actually the representative, I think, of Choice, the Consumer Affairs Group. From within that role, he's been making regular complaints about particular products and some of the claims they make, which are outrageous or they're lies or the misrepresentations or whatever. He's been called a serial complainer because he does it a lot, and he generally gets sort of supported and found out that his complaints are substantiated. Previously, he was going through what was called the Complaints Review Panel, which was part of the TGA. But with the review of the TGA about a year or so ago, that whole system was changed, and the Complaints Review was brought inside TGA. And basically what's happened is that, according to Ken and a number of other researchers who are working with him, that whole process has fallen down. It's got overloaded. It's not doing the proper thing. It's basically clearing complaints by just sending a message to the producer, the alternative medicine supplier, saying, naughty, naughty, don't do that again, and that's it.
And then they just do it again, or alternatively, they just change one word in the name and do it again.
And that's exactly what they do. Basically, they change the name of the product and just put it out again. And it's a ridiculous situation. And at our last convention, there was a bit of a confrontation between the TGA and Ken and a number of other people, quite heated at one stage, but just pointing out that if you have, for instance, a product like that reduces fat, it makes you less obese. And if you take it and it's a load of junk, you complain about it, and the TGA then goes through a process of reviewing that and then saying, no, you can't put out that product. The trouble is, if the company has numerous products along that line, according to the TGA, they have to do them separately. It means it takes ages, if they do it at all. So Ken and some of the others are asking, well, why can't you do a definitive review of, say, all these fat reduction products are potentially shonky? They have to prove that they work rather than the other way around. And that's the whole problem with the TGA system, is that companies who want to get registered on the TGA list, or included, I should say, on the TGA list, is very easy. They just have to go online, fill in some information and say, yes, we have the evidence to prove this product works, and then that's it. They get listed.
It doesn't have to be scientific evidence, it's just hearsay.
They often don't have any evidence.
Oh, right.
They just have to say they have evidence. That's the whole trouble. But they don't get reviewed regularly. Even in the old days, before the review, when they did do a sample review of a lot of these things, 90% of them turned out not to have any evidence at all. In other words, they lied, right, about having evidence. And if they do have evidence, it might be particularly shonky. There are probably some products out there that are genuine, but trying to find the genuine ones from the shonks is very difficult. And with a reviewed system, as it is now, you got less chance of finding it. So Ken basically said, well, enough. And he quit the group that was sort of working on these reviews, on the having a review of all these products. He said, it's just ridiculous. This system is not working. They promised a review of the review after about a year or so to see how it was working, and it's not. The trouble is, the TGA, and this sounds like a conspiracy theory, the TGA is funded by the industry, not by government. It is a public body, but it's funded by the industry. That's not to say they are captured by the industry, but certainly there might be less inclination to go after them in detail. Staffing levels are low, which makes it very hard. The equivalent sort of overseas is the Food and Drug Administration and people like that, which are large organisations. The TGA is a very small organisation, really. And considering the number of products that are listed every year, it probably just can't keep up. So it seems to be taking an easy way out, only going for a few things to assess, which are regarded as the high-risk products, ones that might kill you, which is fair enough. But it means all the ones that don't do anything, that are useless products that you're just wasting your money on, go straight through the system and continue to be sold. So Kenneth has enough.
In the United States, is the FDA funded by the government or by private industry, by the drug companies?
It's basically funded 55% by the federal budget.
Right.
So it comes out of the public sector. The remaining 45% is paid by industry user fees rather than just the straight-out funding. So the TGA is in a very different situation to the FDA.
What about our federal government in Australia? What have they reacted to this at all, or are they hoping it goes away?
I think they hope it goes away. way. I mean, the Health Minister Hunt was sort of very supportive of this review a year ago and saying it will sort of improve the process. It'll get things moving quickly. It'll, sort of people who make complaints will be responded to very quickly. No. It has not happened at all.
Has anyone contacted the federal opposition to get, because usually you find the government works better when the opposition asks questions.
If anyone is going to be contacting anyone going, it's going to be Ken Harvey.
How do you feel about this?
I agree with him. The issue is, okay, they have resourcing problem, right? It's not fully funded. It certainly shouldn't be funded by the private sector to the extent it is. So it's a classic thing. If you have a consumer protection body that can't protect consumers because it's under-resourced or something's just in a too hard basket, you've got to fix it up. I mean, consumers need to be protected. And if all these things, ACCC has the same problems. Do they have enough money to investigate everything? No. Do a lot of shonky things get through? Yes. But these are things that people are spending money on in the alternative medicine field, and possibly, therefore, because they're spending money on this and following this particular alt-med course, they're probably not taking up things that actually work.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.